Hello there, mathletes. Yesterday, we talked about the introduction to absolute value. So we learned what is an absolute value, what is its distance from zero. We simplified stuff inside the absolute value, and then took the absolute value, and guess what? We're going to solve today. So, our goal is to be able to solve an absolute value equation. So what we're going to do today, if you look on your paper, you have the absolute value of G equals 9. So when solving an absolute value problem, you're trying to determine what two numbers are both a certain distance away from 0. And if you think back to yesterday's notes, we saw that 5 and -5 both had the same absolute value. They were the same distance, just going different ways. So what we're trying to think of now is what can we put in here to make this equation true? So you could either draw a number line. Here's your 0. And then you would have 1, 2, 3, 4, 5, 6, 7, 8, running off here, 9, right? You know that 9 is 9 units from 0, so that would make that true. So G is going to equal 9. But what if you went the other way to -9? How many units is it from 0 to -9? And if you said -9 units, not right, but it's a positive 9 units. So if you said it's 9 units from 0 to -9, you're also right. G can also be -9. Notice how there's two answers. There's two answers because if you were to put 9 in for G, you're going to get 9 as an answer like we did yesterday. If you put -9 in for G, so it'd be -9, absolute value of -9, what would you get? How many units from 0 is it? 9. So what we're trying to do is figure out what two numbers can go inside that absolute value to make this equation true. So here's some examples. And if you think back, one of our rules from yesterday was our answer can never be negative unless there's that negative outside the absolute value bars. So let's remember that. Take a look at problem number 1. What can M equal to give you 5? Well, if you say M can be 5, because 5 is 5 units from 0, and M can also be -5, because if you take a look at your number line, you're going to go 5 to the right, 5 to the left, and it's still the same number. Take a look at our absolute value here. Do you have a negative on the outside? If you answered no, you're correct. So how can we get a negative in our answer? If you have an absolute value bar with no negative, and you have a negative in your answer, this is a no solution. It's not possible. But take a look at number 3. See how there is a negative on the outside of your absolute value bars? And you got a negative in your answer? This is a true statement because really those negatives will just cancel each other out, and all you're left with is the absolute value of F is 10. And we can solve it like we did problem number 1. So what numbers can you put in for F to get 10? So F can equal 10, and F can equal -10. Does everyone see how we're doing this? If you don't understand, remember, you can rewind and rewatch. Here's 3 more examples. Always ask yourself, if you have a negative in your answer, do you have a negative outside your absolute value bars? If the answer is no, then again, it's no solution. But if you have a negative out front of your absolute value bars and you end up with a negative in your answer, remember those can cancel each other out and you're left with the absolute value of y is equal to 6. So what can you put in for y to give you 6? Y can be 6, and y can be negative 6. For number 6, what can you put in for z to get 8? Z can be 8, and z can be negative 8. What we're going to do now is make it again a little bit harder and add in an operation. So yesterday we said, let's think of our absolute value bars as parentheses, and let's simplify what's on the inside. Well, now that we have a variable, we really can't do that. But if you notice up here in our answers from the time before, we always have one negative answer and one positive answer. So we're going to use that idea to solve these two. So here's our problem. The absolute value of x minus 2 is equal to 3. We're going to write this twice, but instead of the absolute value bars, you're going to put parentheses around it. Now, again, think about our last one. One was positive, one answer was negative. So in front of only one of your parentheses, make sure you put in a negative symbol. So we're going to go through and solve these equations separately. So I'm going to draw a line so we know we're going to have two answers. So the first one, you would add 2 to both sides. So we're thinking back to 8th grade on our solving skills. Your 2's will cancel, so you have x equals 5. This x equals 5 is one of your answers. But on the second one, we have a negative out front, so you have to distribute the negative to everything inside the parentheses. So you have negative x, and a negative times a negative is a positive 2 equals 3. So if we go through and solve this, the first step you would do is to subtract 2, and you have negative x is equal to 1. And you can't have a negative value on your variable, so we're going to divide by negative 1. And this gives us x equals negative 1, and that is our second answer. So our two answers are x is 5 and x is negative 1. So we're going to go through and solve a couple more of these. I'm going to rope this off. And every time you see this, you're going to do parentheses x plus 5, close your parentheses, equals 11, and parentheses x plus 5, close your parentheses, equals 11. And remember, you always have to put a negative on one of your two equations. So here we're going to subtract 5, and 11 minus 5 is 6. So that's one of our answers. And you distribute your negative. So you have negative x minus 5 equals 11. And in this case, we would add 5. Negative x equals 16. And divide by that negative 1 again. And x equals negative 16. So in this problem, our two answers are x equals 6 and x equals negative 16. And last but not least, we have x plus 3, so I'm going to put that in parentheses, equals 9. And then again, x plus 3 equals 9. The one thing I don't want you to forget is that negative. One is positive, one is negative. So in this first one, we would subtract 3. And you have x equals 6. And over here, you again would distribute your negative, so you have negative x minus 3 equals 9. get rid of that number first, so we do its opposite operation, which in this case is positive. So 9 plus 3 is 12. And you would divide by that -1 to get x to be positive. And I'm going to squeeze this in. X is -12. And those are your two answers. So you can move away from your station, go to a desk, find your in-class practice, start working on that. Again, when you finish, raise your hand, and your teacher will be around to check your work. Have a great day!